In this lesson, we're going to be estimating the value of irrational numbers, and we're going to be doing that on a number line. So I've got my number line set up here, and I've got two marks, one on the far left and one on the far right. This is the way you're going to set it up every time you're estimating the value of an irrational number. So let's say I want to take a guess at the value of the square root of 6. The first thing you need to understand is that radicals you can put in order just like you would any other number. So the square root of 2, square root of 3, square root of 4. While you can find other numbers in between there, these numbers are definitely in order from least to greatest. Now, if you look closely, you'll recognize pretty quickly that not all of these are rational numbers. The square root of 4 is actually 2 times 2, or 2. So put a little note right below there. Square root of 4 is 2. And then over here, the square root of 9, that's 3 times 3. So we can put a 3 below there also. So the square root of 6 clearly comes somewhere between 2 and 3. Let's go up here to our number line. I'll put my 2 there, the 3 there, and then why not? Let's put our irrationals, or our radicals rather. Let's put our radicals on top. So square root of 4 and square root of 9. Somewhere in between 2 and 3 then is the square root of 6. So another useful thing to do is to identify our midpoint. What number comes exactly between 2 and 3? Well, 2.5 or 2.5. Since the square root of 4 and the square root of 6 are only 2 apart, and the square root of 6 and the square root of 9 are 3 apart, we know that the square root of 6 is going to be somewhere in between 2 and 2.5. And it's probably going to be closer to 2.5 than it is to 2 because it's near the middle. So the square root of 6 probably falls somewhere in there. And we could make a guess at saying it's about 2.4. Square root of 6 is 2.4494. So we were sort of close. We got the tenth place right, which is good. So let's do another example. Let's say this time we want to estimate the square root of 67. So we're going to need to find the perfect squares on the left and the right that are closest. So let's see here. I know that the square root of 64 is 8 times 8. And I know that the square root of 81 is 9 times 9. So the square root of 67 has got to fall somewhere in between the square root of 64 and the square root of 81. So we've got square root 65, square root 66, square root of 67. So you can see that the square root of 67 is really much closer to the square root of 64 than it is the square root of 81. They're only 3 apart, and 67 and 81 are, I think, 14 apart. So if we were to identify our midpoint right here at 8.5, not only is the square root of 67 going to be in between 8 and 8.5, but it's going to be much closer to 8 than it is to 8.5 because it's really in the list. It's only 3 away from 64. I'm going to guess that the square root of 67 is right in here, and I'm going to say that maybe it is about 8.15. The digit that matters most is this 10th place digit, but I'm going to guess 8.15 just because I know 8.1 is closer to 8 than 8.5. There we go. Square root of 67 is 8.18. So I was a little bit low, and if we round it up, it'd actually be 8.2. But that's not a big deal. What we really need to understand is that it's going to be somewhere in here, close to 8, but a little bit bigger, 8.1, 8.2, right in that ballpark. Now, finding the exact value is not what we're after right now. We're just trying to estimate the value of irrational numbers. If we want an exact value, we'll probably just go to our calculator. So let's do one more example, and then we'll call that a lesson. So this time I'm looking for the value, an approximate value of the square root of 220. Which number squared is bigger, and which number squared is smaller? So this is where a little memorization can be helpful. The square root of 225 is 15. So then the low end is going to be 14. The next low is perfect square. And 14 times 14 is 196. So the square root of 220 is going to come in between 14 and 15. We need to know, is it going to be closer to 14 or closer to 15? Well, clearly the difference between 220 and 225 is much smaller than the difference between 220 and 196. So let's go in here and mark out our midpoint at 14.5. And then let's make a guess that 220 is going to be right around here, pretty close to the square root of 225. And I'm just going to guess that the square root of 220 is approximately 14.9. So here we go, square root of 220, it was 14.8. So I was close, but I was guessing a little high. So the first step is always to locate the perfect square that is closest on the left, and mark that on the left side of our number line, and the perfect square that is closest to the right, or closest on the right, and mark that on the right side of the number line. So in this case, it's 81, because 9 times 9 is 81 on the left, and 100 on the right, because 10 times 10 is 100. And then we'll find the midpoint for the next step. So halfway between 9 and 10 is 9.5. And then the last thing we want to do is examine the difference and make an educated guess. So the difference between 81 and 90 is 9, and the difference between 90 and 100 is 10. So that tells me that the square root of 90 is closer to 9 than it is to 10, but it's really close to the middle because the difference is almost the same. It's only a little bit closer to 81 than it is to 100. So we'd make our guess somewhere close to the middle, and I'll say 9.43. Right around here somewhere. And I was close. I got the 10th place right, but not the 100th place. It was actually 9.48. So it's really very close, even closer to 9.5 than I guessed, probably right about here.